Okay, this is the P1 paper from June 2024. It's question number 7, and as you can see by looking at it, this is a differentiation question. We're going to be finding f-x and f-x. A little bit further on down the question, when we get down here, we're also going to do some work solving quadratics. But let's have a look at the question. It gives me my function fx here, and what we'll notice is there's a k in my function. That's not going to cause me any problems, and ask me simply, can I find f-x and f-x in simplest form? Yep, absolutely I can. So we had that fx was equal to 2x cubed, but as we said, minus kx squared plus 14x minus 24, and then all we're doing for part 1 is differentiating f-x. Remember, differentiating, multiply by the power, take one off the power. So I'm going to get 6x squared. I'm going to get minus 2kx here. By the time I get down to x's, we just have the coefficient, and the minus 24 will disappear. Part 2, because that's part 1 done, says f-x. So again, multiply by the power, take one off the power. I'm going to get 12x. I'm going to get just my 2k with the x there, and the 14 will disappear. So absolutely no problem, f-x and f-x completed. It then says the curve with the equation f-x intersects with the curve with the equation f-x. What that means is I'll put those two things equal to each other. It tells me they intersect at points A and B, but it tells me that the A1, the solution, the x part of the solution, will be A equals 5. Right, I know exactly what I'm going to do now then. I'm going to put this equal to this. I'll get some equation which I'll need to solve, but when I'm trying to solve the equation, because I've got x's and k's in there, I know that x is going to be equal to 5 will be a solution, so it means I'll be able to work out k. Let's tell the examiner what I've just told you. So part B, where the curves meet, we're just going to get 6x squared minus 2kx plus 14 will equal 12x minus 2k. Now, normally I'd set the quadratic to be equal to 0, so let's do that. You could, by the way, you could just put x equals 5 straight in here and solve it. And if you don't like doing too much algebra, that might be the thing for you to do. I'm just going to set up for possibly my next part after this. So I'm going to say 6x squared minus 2kx plus 14 minus 12x plus 2k works out to be equal to 0. And then I'm going to go one step further here, and I'm actually going to say, let's combine the x's together, and then after that, let's combine the coefficients together, the constants. So here I'll have 6x squared, and I'm going to take a minus out actually and say 2k plus 12x, and then I'm going to say 14 plus 2k. You didn't need to do all that. You could have just jumped straight to this next step, which is to say at x equals 5, what do I get? And you could have plugged that in up here to get your equation. Would be a bit quicker. I'm sort of setting this up for the second part just in case I need it, or part C rather. So 6 lots of 5 squared minus 2k plus 12 times 5 plus 14 plus 2k equals 0, and work out all those values. I get 150. I get, if I multiply everything out as well, minus 10k plus 60 plus 14 plus 2k equals 0. Well, that all tidies up to 104 minus 8k equals 0. So k equals 104 over 8. K works out to be equal to 13. So if k works out to be equal to 13, this is going to help me now for part C. So part C says, right, can we find the coordinates of B? So coordinates, notice, I want the x value and the y value for B. In order to find the x value, I'm just going to find the other solution to the quadratic. So this is why I did the work previously, was just to make this maybe a little bit quicker for me to do. There's my quadratic, and what I'm going to do, let's do this for part C. So my quadratic was 6x squared minus 2k plus 12 times x plus 14 plus 2k equals 0, but I know that k is equal to 13. So if I put k equals 13 in there, I'm going to get 6x squared. I'm going to get minus 38x there, and I'm going to get plus 40 equals 0. So what I need to do now is to solve this quadratic, and when I solve this quadratic, I'll get x equals 5 as one of my answers, and x equals whatever this one is will be my b coordinate, and it'll only be the x part of my b coordinate. I'll need to work out x and y for my question mark there. But actually that helps me. So you can go and solve this now. You can factorize it using the AC method. You can stick it into the quadratic formula if you want. Both of those will work. I'm just going to take a little bit of a shortcut in the fact that I'm going to try and work out what it factorizes sort of almost in my head here. I'm not suggesting you do this unless you're a pretty strong student. But what I actually know here is, as I'm looking at it, if I've got 6x squared minus 38x plus 40, what I've got to try and do is get one of my answers to be x equals 5. So I've either got x minus 5 there and 6x and try and work it out. Well, I've done this previously already, so I actually know what my answer is going to be. It's 2x minus 10 in there, which makes it much easier now to try and work out what that's going to be. It has to be 6x squared, and play around with the numbers a little bit. But we know that minus 4 times minus 10 is 40. If that's a little bit too much for you, just stick it into the quadratic formula. You're still going to get the same answers. I'm trying to save myself a little bit of time here. But as with all questions, much more important that you get it right than you try and rush it with some quick method. Okay? So, yeah, moving on from this one, this is going to give me 3x minus 4 equals 0 or 2x minus 10 equals 0. I don't really need to do any more work for that. I knew that that was x equals 5. That was one of my answers. But 3x minus 4 is going to give me x equals 4 over 3. Now, what I tend to do when I'm actually doing these exams is I would have, right at the start of the question here, done that so that when we come back to this question and think, oh, we're finished, you know, done a minute or so's worth of work, it reminds me, no, they didn't just want the x coordinate of b, they actually wanted the coordinates of b. So I've got x equals 4 over 3. I've got to work out the y. So what do I put it into? Well, I can put it into either of these two equations. The y, sorry, not either of these two equations. I can put it into, too far, either this one or this one, and I'm going to choose the easiest one to put it into. So I'm going to be putting my x back into that value there. Tell the examiner what I'm doing. So for y equals 12x minus the 2k we had. Remember, we know k is equal to 13, so it's equals 12 lots of 4 over 3 minus, this is 26 now, isn't it, because k is equal to 13. So y works out to be equal to minus 10, and I just finish it off. B is the point then, 4 over 3 minus 10. Relatively easy question, but just make sure we don't fall into any traps and not complete it because we're not concentrating. But hopefully that makes sense to everybody.